Let's turn this off. Oh, I'm in this world, this is strange. So, if I may, Elizabeth had an I'm going to put it right in here. Elizabeth, your idea was take the 1, 4, the 7, the 10, and the 13. So I'm going to call those my data. If that's okay with you guys, I'm going to call those my X's. 1, 4, 7, 10, 13. Should I just average those 5 and divide by 5? Tom's shaking his head. He's like, dude, don't do that. What? Tom, why?
They're not even in the room.
Okay, you could get away with that if there were the same number of 1s as 4s, as 7s, as 10s, as 13s. Be no problem with that, with doing that, because it would all be evenly weighted. So what you're learning about now at the very last of class, and we'll pick it up again on Thursday, is something called a weighted average. How do you take an average of data when the data itself is not evenly distributed? Beautiful. So what you have to do is I'm going to create a column here called the F column. The F column is going to be frequencies. We've already used that word, frequency. Now, I'm going to need your help on this one. Was it 10 ones?
Yeah. 17.
17? Thank you. 5? 1, 2, I believe, yeah? Let's double check to make sure I didn't screw it up. I'm going to add up the frequencies.
35.
Is that 35? Good. That's what it should be, right?
Mm-hmm.
Because what does summing up the frequency sum up, actually?
Number of people.
Number of people in the room. Well, we did the survey. Each of you, everybody in this room was in one of these categories, assuming you were here and you gave me a vote that day. Beautiful. So, hell, this is great. This is like little n, isn't it? That's like the sample size. That's what we would divide into using the formula over here. That's what we would divide right there. Yay. But what's on the top?
The X.
Is it the x's? So we go 1 plus 4 plus 7 plus 10. That's 14 plus 14 is 28, 35. Oh, 35 is 1. That's a clever coincidence. But Katie's like, no, that's not quite right, is it? What are you thinking? What goes in the top? Now, forget the number for a second. Forget the number for a second. Go back to over here. Go back to this calculation. When we actually put, I believe the number up here was 128? 148 or 140 something? 142, thank you, 142. What was that number? 142 what?
Keys.
Number of keys total in the room that day, right?
Yeah.
Well, that has to also go there, in this average too. It has to be, the average has to be the number of keys in the room divided by the number of people. And the number of people, we already have figured out, it's just the summation of F. That's going to be the number of people, it's 35. The trick is we need to get an approximation for this from that chart. How can we do that?
Is that F by X? F multiplied by X?
Say that again, Kelly.
F multiplied by X in each.
Explain to me why that makes sense.
Because there's, hold on.
No, I'm already, so what you're saying is do this, X times F?
Yeah, because there's, they're groups of numbers.
Yes! 10 people each have 1 key.
10 times 1.
They bring 10 keys to the table. Fair? 17 people each have 4 keys. They bring
68?
68 keys to the table. 5 people
35.
bring 35 keys to the table.
Well, I can do the next one.
You can. I can too. 10.
Yeah, 10.
Oh, 26. Oh. Now, here's the part I love.
Get it.
Add those up, right?
142.
Does it go out to 142?
That's like Rain Man right there.
Oh, it should come close. If that comes out there's only 142, I pass out. Let's do it. 78, 113, I think, right? 113, 123, 149.
Oh!
Extra 7.
Damn, that's okay. It's damn close. 4.2 on average, 4.3 somewhere in there. Is that what it comes out to be? To 1 decimal, what is it, friends? 4.2, 4.3. Just throw it out there. I can't do it in my head. I'm sorry.
It's 4.3.
4.3.
Wow.
Isn't that badass? You don't have to have the raw data to get damn close on this. And that's the point. Sometimes damn close is good enough. And in a case like that, if you're doing a research project and that's all you've got is that data collected in that histogram form, you can still get a good solution value, even without the raw data. It's pretty cool, huh? I think it's pretty cool. You might not think it's cool yet.
That's an
Too close to
awesome-
lunch. Low glycemic index, maybe. That's okay. But that's badass. Statistically, that's badass. Now, some of you might be concerned. Wait a minute. What if this just happened this time? Right? What if it good? David's already like, wait, I thought it like half an hour ago. I have an Excel spreadsheet. We have 4 minutes left. Let's not look at it now. Let's bring it up first thing tomorrow. I've been building simulations to illustrate what Sandra actually brought up about 20 minutes ago. We made some assumptions when we called these 1, 4, 7, 10, and 13, didn't we? We said on average, the zeros cancel the 2s, you end up with 1s. Well, that's on average. That doesn't mean in every category. But what tends to happen with data is, if one category is a little low, some other category is going to be a little high, and it is going to balance out. And I can tell you, I've been teaching this stuff for 20 years, 3 times a year, 2 times a year. I have never had an average value in this experiment off by more than half a key. And when half a key, I was like, there's something wrong. Because that even seemed too much to me. But it's not. That's what's going to happen eventually. Occasionally it comes up exactly the same. Very rarely it's usually off by 1 or 2 keys. The sum is off by 1 or 2 keys, which means the average is off by 1/10 of a key. Boggles my mind every time. That's why Kate, you said 142. I was like, what? Shouldn't be that close.
Let's try next one.
Good for you. Good for you. It was awesome. I loved it. Okay. We'll do more center on Thursday. Dave, you have a question or you just take it all in? Go ahead. Go ahead.
I was just going to say that might be because it was a measure of keys, which most people won't have an extreme number of.
Believe it or not, we'll look at the historical values on, I have one kid that brought 29 one day. Now, of course, most kids don't. He was the extreme, but we can slap him in and see how it compares to your curve as well. It's fun. It's fun. We'll see you guys Thursday. Be well. Try some quizzes.
What's that?
Try some quizzes.
Okay.